I'm Dennis Semeka, Senior Editor for Technology at Industry Week. Welcome to our new video series, Smart Manufacturers. Most of us are probably familiar with the term 5G in the context of our smartphones, tablets, and other devices. If you have a 5G connection, that means you're getting stable connections with fast download speeds. 5G is nothing new in the consumer world. 5G home internet service began in late 2018, and 5G smartphones hit the market in 2019. In the manufacturing world, however, 5G is still finding its place. The technology is usually discussed in the context of private cellular networks. If manufacturers want to take full advantage of IoT systems, adding new devices as their network expands, and eventually capturing data plant-wide, 5G can be a powerful tool toward that end. There are only a few organizations with the know-how to manage a private cellular network for manufacturing. The majority of them are vendors like Bosch Rexroth, Rockwell, and Siemens. But among this group stands one manufacturer, John Deere. The company's Waterloo Works plant in Waterloo, Iowa has become a gold standard for 5G technology deployment in a manufacturing setting. Jason Wallen, John Deere's principal architect at Waterloo Works, led the effort to bring the 5G network online.
When we think about networking historically inside the John Deere plant, there had always been some connectivity dating back to the 90s of connectivity between the PLCs and the systems that they needed to connect to make very tactical decisions. But based on that, we also knew that we needed more strategic insights and needed more data to be able to collect that. That led to the advanced networking that we see today in our manufacturing environments.
Two of the core concepts that define smart factories in Industry 4.0 are data capture and analytics. The more machines you connect, the more data you collect, and the deeper your analytics can dig into plant operations. For example, let's talk about automated guided vehicle or AGV safety at Waterloo Works. This AGV is used to transport tractor chassis throughout the plant. The AGV must constantly pass safety checks before it's allowed to continue moving. And there are 36,000 mistake-proofing steps tied to AGV movement. Each one of those steps is a potential data point for capture to improve AGV safety routines. Or we could talk about the plant's roll test bays, and there are 112,000 designed test steps. Each test step is a potential data point to help improve rollover protection structure design. All told, Waterloo Works tractor assembly operations provide 700,000 unique data points per workday. Testing processes provide around 2.8 million data points, again per workday. We're talking about a highly networked plant. Early connectivity efforts utilized hardwired Ethernet technology. John Deere then upgraded to Wi-Fi.
What is the advantage of using Wi-Fi in networks versus using traditional wired Ethernet? There are really a couple big advantages that I see in using the Wi-Fi over some of the existing Ethernet that we have inside manufacturing plants. The first one is the cost associated with the Ethernet is very, very expensive. Secondly, it is very, very inflexible, meaning you can't move it 10 feet to its next location without disassembling that cable and then installing new cable to be able to support that run. Sometimes we found in the manufacturing environment that can take weeks or even months to be able to schedule that delivery of those new network drops. Wi-Fi gives you that flexibility to do that.
The Waterloo Works plant is the birthplace of JDAT, the John Deere Assembly Assist tool, a system that, among other functions, can monitor step completion during assembly, making sure the correct tools are used at the correct times and actively prevent operators from making mistakes. Any JDAT-equipped tool connected to the plant's network generates data that John Deere can use to determine where errors are commonly detected and corrected.
Historically, we've had a lot of connection for the OT to the IT environment there. A lot of the decision points that we needed to make were very tactical in nature within the single cell inside a work stream, meaning that we have a torque wrench that needs to provide an input to our MES system, and then when it does that, it allows it to move forward.
In an Ethernet-based system, each one of those network tools or machines might require its own Ethernet cable. Imagine the chaos of trying to reposition a dozen or more of these tools with all the cabling that may need to be disconnected and reconnected. A Wi-Fi system eliminates this particular problem, but still isn't a perfect solution.
But there are some downsides to Wi-Fi as well, meaning that things that move around the shop floor do not transition from access point to access point very seamlessly. We see a big change in latency between devices there or in instability. We also know that the density that Wi-Fi can support is not as great as what we can support with the Ethernet technologies.
By access point, we mean the physical hardware that accepts Wi-Fi signals from a device and transmits that data elsewhere. If a tool is attached to an access point and then the tool is moved across the plant, the tool might have to be paired to another access point that's physically located closer to the tool than the first access point. So now, instead of worrying about physical cables getting mixed up when connected devices move around the floor, we're talking about wireless signals crisscrossing and potentially falling off the network until it's reconfigured. And the more devices you want to connect to Wi-Fi, the more access points you have to install. Or you could just switch over to 5G.
Why upgrade to 5G technology? I think in our case, there are very good business reasons to be able to do that. The first is things that move around the shop floor require that ability to hand off very, very cleanly. Cellular and private 5G give us that opportunity to manage that connection between those devices that moves about the shop floor with a very, very repeatable latency. That's just because of the technology and the algorithms that are built into the protocol and the make before break transition technology that doesn't exist in the Wi-Fi. So that was a very clear case to do that. In addition to that, it is also very, very important that we be able to support a high level of density. And in a traditional Wi-Fi access point, we can support about 50 devices effectively. In our microcells, we're able to support 800 devices, and we can support several thousand devices in our small cells that we have connectivity.
John Deere had substantial experience working with cellular technology before construction of the Waterloo Works 5G network began in 2020. The company's Modular Telematics Gateway, or MTG, combines several technologies, including 4G cellular, to provide machine health monitoring, diagnostics like fuel usage and location tracking, and enables networking the tractor with smart devices in the field. The MTG premiered in 2002, became standard equipment for all John Deere tractors in 2009, and is the heart of John Deere's smart farming systems.
One of the things that really excites me about John Deere is we're not afraid to be leaders in technology. We've seen that in our tractors. We've had connectivity provided via cellular networks and more recently satellite networks since 2006 inside all of our vehicles. In the same way, we took that knowledge of what we learned in our products and made our manufacturing as smart as that. So this was an initiative that was sponsored both by the CTO organization as well as the CIO organization, solved a lot of the problems that we've traditionally had with silos in the past when you have both of them team up and say, this is really our North Star. We know we need more data from our networking environment. And because of that, the only way we can be successful is finding the right connectivity solution that helps us get that data stream that we need.
If a manufacturer has already spent a significant amount of time and money wiring its plants with Ethernet or Wi-Fi based connectivity, the idea of abandoning those technologies in favor of 5G might be upsetting. But the infrastructure laid down for those technologies also supports a 5G network.
I think one thing that is interesting, a lot of the fundamentals are very much the same between the different flavors of networking. The first part of that, Ethernet, and what we've done there around being able to provide a security perimeter to ensure the safety of our data, is just the same technology that we would use inside the cellular networks as well. So the investment we've made there carries over and goes further. And we have also been able to extend that beyond where we initially were with the private cellular. So because of that, we get that very repeatable, reliable connection that gives us the good security with that as well that we've had previously and allows us to extend that even beyond where that's been.
Building the right skill sets to manage a private cellular network without depending on vendors or third parties presented a significant challenge for John Deere. Thanks to its experience with cellular connectivity and its tractors, the company understood generally how to implement the technology. But those efforts depended on public carriers, not a private network, and finding the right people to manage its burgeoning private 5G was almost impossible.
We think about the skill sets that it takes to manage these types of networks in a manufacturing environment. That's a strong understanding of a manufacturing OT environment. It's an enterprise networking focus in how we think about segmentation and division, and then also how we manage the cellular networks. That is an almost impossible skill set to find. So because of that, we really found folks that had 2 out of those 3, and then we upskilled them in the final area that they had to be able to build well-rounded individuals that understood all 3 levels of those expertise. And that's kind of how we dealt with that. That's how we dealt with the fear of the unknown in running our own cellular networks.
The 5G production network at the Waterloo Works plant is up and running as of August 2023. It's too early to gauge what effect running 5G alone will have on the plant in terms of overall equipment effectiveness, error prevention, or other overarching KPIs. However, looking at the system strictly from an IT perspective, it already sounds like a complete success.
When we think about ecosystems and networks and needing to patch those networks, taking those down for maintenance windows there, over the past 18 months, We've seen 60 different times that this Wi-Fi network has been impaired for various reasons there, whether that was hardware failure, whether that was software bugs, misconfiguration, those type of issues. In the cellular world, because we've designed the solution with full RF redundancy to be able to support multiple connections and be able to do active in-time upgrades with taking half the network down, making the upgrade, bringing it back up, bringing the other set of networking technology down, then making that change, we've had no downtime for the cellular networks in our factory at Waterloo Works.
John Deere does have some early success stories for the 5G network at Waterloo Works. Back when the plant depended on Wi-Fi for connectivity, John Deere found it challenging to wire enough machining centers with vibration sensors to gather enough data to train predictive maintenance models. This ceased to be a problem once the 5G network was up and running, and John Deere could greatly increase the number of networked vibration sensors at the plant.
I think one of the key things that we see that is different because we have private cellular connectivity in the environment is quite simply our manufacturing data lake, that we have manufacturing data that has that digital thread or the digital twin of our products has been able to expand greatly because we are now able to capture new data streams that we've not previously been able to do. This gives us more steps of product validation to make sure that we have the quality that our customers demand, and then our ability to do analytics to make sure that we continue to improve our designs to make even more quality vehicles than what we make today.
We asked Wallen if a manufacturer hears about what John Deere has implemented at Waterloo Works and decides they're interested in piloting 5G technology themselves, how do they choose the right plant at which to deploy the pilot?
I think it's very important when you think about what is your lighthouse plant or where do you go to do your proof of concept work when you have multiple plants in multiple locations. You know, there are a couple of design patterns that we found are a very, very good fit for private cellular. Those technologies include things that move around the shop floor, so logistics robots, AVGs, being able to understand those. Connected forklifts are another great example, so when you have to move materials from one place in the plant to the other place in the plant. Also being able to use RFID for advanced location services are another great opportunity to investigate private cellular and the technologies that it brings as a complementary stack with that. All of that to say, having where you would like to implement some things that you've not been able to implement is very, very important to be able to prove out the value of private cellular in your factories.
Long-term, John Deere does not plan to entirely replace Ethernet and Wi-Fi technologies with 5G. There will always be appropriate use cases for these other technologies, and so the company expects that over time, 80% of its factory connectivity will be provided by private cellular, 10% will remain on Wi-Fi, and 10% will remain on Ethernet. So, again, current use of Ethernet and Wi-Fi networking technologies is not made irrelevant by embracing 5G. Private cellular just becomes another tool in the manufacturer's toolbox. Thank you for joining us today. I'm Dennis Semeka, Senior Editor for Technology at Industry Week. We'll see you next time on Smart Manufacturers.